All right, so the concept of reciprocal lattice can be quite abstract. And so I want to stop for a minute and kind of prove to you some of the stuff that we've just talked about, because it can be a lot to take in. So we talked about this DHKL star vector in reciprocal space. And I want to show you that that vector, which we can get in reciprocal space, is the equivalent of 1 over the interplanar spacing for the same HKL values, because this is an important thing, right? Because then I can use reciprocal space to get information about the spacing between planes. So I want to show you that relationship. And so the kind of the proof here that I'm going to show you is from the Cullity book in Appendix 1, and it's section A1-3. So just in case you want to sort of go into it a little bit more detail. All right, so I need to draw my real space A, B, and C vectors, right? So I'm going to draw them like this. So this is A, this is B, sorry, and this is C. So this forms our unit cell, right? I can draw a unit cell as such. Right? So that's my unit cell. So I basically just made a more generalized A, B, and C, right? So they're not all, so I'm trying to show you that they're not all 90 degrees apart and so forth, right? All right, so what I want to show you is, again, I want to show you the relationship between this D star and 1 over D. All right, so I know that from definition, the C star is equal to A cross B over the volume. So basically, if I take the cross product of A and B, meaning it's going to be normal to that, I have the C star vector, right? Because it's the cross product, so it's the effectively normal to the area of A and B. So the cross product A cross B, that's the same thing as looking at the area of this parallelogram that we call, and let me put some labels here. So this is the origin. I'm going to call this point A, this point C, the point back here B. So effectively the parallelogram OACB, right? So that's the cross product. So I've got C star is equal to the area of OACB. And then I know that the volume, right? So we're talking about the volume of the unit cell. So we can define that as also the area of OACB times the height of the cell. Right? So we can get that as the height of the cell. All right, so we know that the volume is the area times the height to get the volume of this unit cell. Well, we already know this part, but the height we can see is basically the point right there. And if that's the 90-degree angle, we can call that P. So this height is also OP, right? So effectively, the C star vector, these two things cancel out, and we get 1 over OP, right? Well, if we think about what OP is, right? If we think about the 0, 0, 1 plane, right? That would be this plane up here. And then we would also have a plane down here that's also of the type 0, 0, 1. Well, the distance between those planes is equivalent to the length OP, right? That length OP is the same as saying we have 1 over the d spacing of 0, 0, 1. Because OP is the same as d 0, 0, 1. Right? So I just tried to show you with the sort of geometry of a simple cell, and particularly for the 0, 0, 1 set of planes, that we can get the C star, which is the same thing as d. So in this case, d C star vector is the same thing as the dh001 star vector. And so that's equal to 1 over OP, which is also 1 over d001, the length of it. So I just wanted to kind of show you with a simple geometric arrangement that, yes, in fact, the star vector is equivalent to the length of the interplanar spacing 1 over the reciprocal of it in real space.